The kinetic energy of emitted electron is E when light incident on the metal has wavelength lambda. To double the kinetic energy, the incident light must have wavelength A, hc by E lambda minus hc, B, hc lambda by E lambda plus hc, C, h lambda by E lambda plus hc, D, hc lambda by E lambda minus hc. So we know the formula for energy. E is equal to hc by lambda. So in the first case, kinetic energy of emitted electron is E itself. So we have E and the light incident as wavelength lambda. The second case, we have to double the kinetic energy. So we have 2E is equal to hc by lambda dash. Some lambda we do not know. That is what we have to find. Now we can subtract this equation from this equation. So we have 2E minus E is equal to, we're subtracting this equation from this equation. So we have hc by lambda dash minus hc by lambda. So 2E by E is E. E is equal to hc into 1 by lambda dash minus 1 by lambda. Now we can do cross multiplication. We'll get hc into lambda minus lambda dash by lambda dash lambda. Now we can do hc common we can take. So we have E into, we can take lambda dash lambda is equal to hc lambda minus hc lambda dash. We're doing this so that lambda dash all go to one side. So we can take lambda dash term here. So now let us take E into lambda dash plus hc lambda dash is equal to hc lambda. Now take lambda dash common, we'll have E lambda plus hc is equal to hc lambda. Now we can isolate lambda dash, we'll have hc lambda by E lambda plus hc. So we got our lambda dash term. Now let us check in the option. So we can identify that option B is the correct match.